the transfer characteristic curve of a transistor having input and output resistance 100 ohm and 100 kilo ohm respectively is shown in the figure. The voltage and power gain are respectively. Option A, 2.5 into 10 raised to 4, 2.5 into 10 raised to 6. Option B, 5 into 10 raised to 4, 5 into 10 raised to 6. Option C, 5 into 10 raised to 4, 5 into 10 raised to 5. Option D, 5 into 10 raised to 4, 2.5 into 10 raised to 6. So in this question, we are given with the graph of IC versus IB, where IC is nothing but output current and IB is input current, and this is called as transfer characteristic. So in this graph, we can see this graph of common emitter configuration of NPN transistor, which is a straight line. So what we have to find is power gain and voltage gain. To find voltage gain, let's make the formula of voltage gain and power gain. Voltage gain is nothing but output voltage upon input voltage, where voltage gain is represented by AV, where V is written in subscript. So AV is equal to V out upon V in, which is equal to output voltage is equal to output current into output resistance. Output current is IC, output resistance is R out, and input voltage is nothing but input current into input resistance, where input current is IB and input resistance is R in. In this question, we are already given with R out and R in. What we have to worry is about only IC and IB. Yes, we are given with the graph of IC and IB. Anyways, IC upon IB, yes, you remember this. IC upon IB is nothing but current gain represented by beta. Beta is equal to I out upon I in, which is IC upon IB. So IC upon IB can be replaced by beta, and AV becomes beta times R out upon R in. Now, let's make formula of power gain. What is power? Power is current square into resistance. So power gain is represented by AP, where P is written in subscript, which is equal to P out upon P in. Output power is output current squared into output resistance. Output current is IC, so IC square into output resistance. P in is nothing but input power, which is IB square into R in, where IB is the input current. So now here we can take square common, and IC upon IB again it is equal to beta. So taking square common, we can write IC upon IB as beta, and we can make the formula as beta square R out upon R in. So now we have formula of AV and AP, which is voltage gain and power gain, where we need to calculate beta for both, and then we'll be substituting the value of R out and R in, where R in is 100 and R out is 100K. So let's find the value of beta. Beta is nothing but IC upon IB. So let's come back to the graph. If we see in the graph, IC is on y-axis and IB is on x-axis. So what we have to do is find the beta, which is an IC upon IB is nothing but the slope of this graph. So we can take any of the point, which is 100, pi or 200, 10 or 300, 15 or 400, 20. We can divide y quantity to the x quantity, because on y-axis IC is given and on x-axis IB is given. So we can take 5 divided by 100 or 10 divided by 200 or 15 divided by 300 or 20 divided by 400. Any of this division will give us value of beta. So answer of beta comes out to be 50. Now we know the formulas of AV and AP. We also know the value of beta. So if we substitute all this value, the answer of AV comes out to be 5 into 10 raised to 4, and answer of AP comes out to be 2.5 into 10 raised to 6 if you do the calculation. So correct answer is option D.